Most students don't understand moments. They memorize signs, clockwise, counterclockwise, positive, negative. And during the exam, everything collapses. Let's fix this properly. A force does not only push or pull. Sometimes it tries to rotate a body. This rotational effect is called a moment or torque. Imagine a door. When you push it, it does not translate through space. It rotates about the hinge. The cause of this rotation is the moment. Sometimes the rotation is visible. Sometimes it only tries to rotate. Even if nothing moves, the moment is there. A moment has two key aspects: magnitude and direction. If the door rotates faster, the moment is larger. In physics language, we say the moment is stronger. And of course, it can act in one direction or the other. So what controls the magnitude of a moment? Three things: the force, the distance from the pivot, and the direction of the force. First, the force. Push harder, and the rotation increases. In other words, the moment becomes stronger. Second, the distance. If you push near the hinge, almost nothing happens. But if you push at the edge, the door rotates easily. Same force. Very different effect. So we see that the larger the distance from the pivot, the stronger the moment. As Archimedes famously said, "Give me a lever long enough and a place to stand, and I shall move the world." Third, the direction. The most effective way to rotate the door is to push perpendicular to it. If you push along the door, toward or away from the hinge, almost nothing happens, even if the force is large. Now, we are ready for the mathematical definition. The moment about a point is force times distance times the sine of the angle between them. This is the formal expression, but we can reorganize it in two intuitive ways. First, combine force and direction. The term force times sine of the angle is simply the perpendicular component of the force. So we can think of the moment as perpendicular force times distance. Here is the physical meaning. At the same distance from the pivot, we could replace the original force with a smaller force, applied perfectly perpendicular. As long as this smaller force is equal to the perpendicular component, the effect is exactly the same. Same rotation tendency. Same moment. Second, combine distance and direction. The term distance times sine of the angle is the perpendicular distance from the pivot to the line of action of the force. We call this the lever arm. So the moment becomes force times lever arm. Again, there is a physical meaning. We can keep the same force, but apply it closer to the pivot. If we apply it perfectly, perpendicular. A shorter wrench, but better direction. And if the lever arm is the same, the effect is the same. Same rotation tendency. Same moment. Same physics. Three perspectives. Once you see this, moments stop being abstract. They become something you can feel. If this finally made sense, this is exactly how the full course is built. In Physics and Structures Made Simple for Architects, we go step by step, from intuition to diagrams to real structural problems. If you want the complete system, you'll find it in the link below.